Dear students, good morning. The last unit in the special functions is Laguerre polynomials. So the first topic in this unit is Laguerre's equation and its solution. So x y double dash plus 1 minus x into y dash plus n into y equal to 0 is called as the Laguerre's equation where n is a positive integer. So to find the solution, we again use the method of Frobenius. So here we will take the ascending powers. So let us, the solution of this series is y equal to summation Cm x to the power of k plus m is from 0 to infinity, c0 is not equal to 0. So by differentiating with respect to x, we will get y dash and y double dash. Then substituting the values of y dash and y double dash in the given equation, that is equation 1, we will get this equation. Now this can be written as summation k plus m into k plus m minus 1 into x to the power of k plus m minus 2, that is x to the power of k plus m minus 1, and multiplying this with 1 into this and minus x into this plus n into summation cm x to the power of k plus m equal to 0. Now taking summation cm into x to the power cm into k plus m into x to the power of k plus m minus 1, from these two terms, taking the summation k plus m into cm into x to the power of k plus m minus 1, you will get k plus m minus 1 plus 1. Next, from these two terms, taking minus summation cm into x to the power of k plus m as common, you will get k plus m minus n equal to 0. Then by simplifying this equation, you will get summation cm into k plus m whole square into x to the power of k plus m minus 1 minus, then this is summation cm into k plus m minus n into x to the power of k plus m equal to 0, that is denoted by equation 3, and this is an identity. So to get the initial equation, we equate the coefficient of x to the power of the least power, smallest power, x to the power of k minus 1 in this equation to 0, then we will get c0. So taking m equal to 0, we will get c0 into k square equal to 0. Here c0 is not equal to 0, so k square equal to 0. That means the roots are equal. Next, equating the coefficient of x to the power of k plus m minus 1 to 0, we will get cm into k plus m whole square minus cm minus 1 into k plus m minus 1 minus n equal to 0. From this equation, we will get cm like this, which is denoted by equation 5. Now when k equal to 0 is the root, so substituting k equal to 0, this equation 5 reduces to cm equal to m minus 1 minus n by m square into c m minus 1. Now equation 2, that is y equal to summation cm x to the power of k plus m equal to 0 to infinity, that can be written as, here k equal to 0, so it is summation cm into x to the power of m. So expanding this summation, you will get c0 plus c1x plus c2x square plus so on, which is denoted by equation number 7. Now putting m equal to 1, 2, 3 so on in this equation, you will get, first if we substitute m equal to 1, then c1 equal to 1 minus n by 1 square into c 1 minus 1, that is minus 1 by minus n by 1 square into c0, that can be written as minus 1 by 1 factorial whole square into n into c0. Next, substituting m equal to 2, you get c2 equal to minus 1 whole square into n minus 1 by 2 factorial whole square into c0. Similarly, you can write c3 so on. The general term is cr equal to this is minus 1 whole cube, C3 equal to minus 1 whole cube into n minus n into n minus 1 into n minus 2 by 3 factorial whole square into C naught. So generalizing this, you will get the general term CR equal to minus 1 whole to the power of, here C3 is 3, so minus 1 whole to the power of R into, this is up to n minus 2, so n into n minus 1 into n minus 2, so on n minus of R minus 1, that is n minus R plus 1 by 3 factorial whole square. So here we get R factorial whole square into C naught for R is less than or equal to n. If R is greater than n, then we will get Cn plus 1 equal to Cn plus 2 equal to Cn plus 3 equal to so on 0, because if you take here R equal to n plus 1, then it is n minus of n plus 1 plus 1, that is n minus 1 plus 1. So the term get cancelled, so we will get it is 0. So if R is greater than n, Cn plus 1 equal to Cn plus 2, Cn plus 3, so on, all the values are 0. So with these values, equation 7, so our equation 7 is y equal to, equation 7 is y equal to C naught plus C1x plus C2x square plus so on. So substituting the value of C1, C2, so on, CR, so on, we will get it as y equal to C naught plus value of C1 plus value of C2, so on, value of CR, so on. So taking C naught as common, we will get C naught into this 1 minus n by 1 factorial whole square into x plus n into n minus 1 by 2 factorial whole square into x square plus so on. So that equal to C naught into, this can be written as in the summation form as summation, the general term is minus 1 whole to the power of R into n into n minus 1 into so on n minus R plus 1 by R factorial whole square into x to the power of R. R is from 0 to infinity. Now that equal to C naught into summation minus 1 whole to the power of R into, now multiplying and dividing by 1 into 2 into 3 into so on n minus R, so that we will get summation R equal to 0 to n, because if R is greater than n, all the values Cn plus 1, Cn plus 2, so on are 0. So we will take only R equal to 0 to n minus 1 whole to the power of R into n into n minus 1 into so on n minus R plus 1. Now multiplying with this and dividing this into R factorial whole square into x to the power of R. So that equal to C naught into summation minus 1 whole to the power of R into the term in the numerator is nothing but n factorial by here 1 into 2 into 3 so on n minus R can be written as n minus R factorial into R factorial whole square into x to the power of R. Now taking C naught equal to 1, this is C naught equal to 1, then you will get y equal to summation minus 1 whole to the power of R into n factorial by n minus R factorial into R factorial whole square into x to the power of R. R is from 0 to 1. Then this is called as the Laguerre polynomial of order n, and it is denoted by ln of x. Thus ln of x is summation R equal to 0 to n minus 1 whole to the power of R into n factorial by n minus R factorial into R factorial whole square into x to the power of R. Now if you take another Laguerre polynomial of order n, this is Laguerre polynomial of order n, I have already explained. Now alternative definition of Laguerre polynomial of order n is, in this if you take, we have this equation 8, if you take this C naught equal to n factorial, then it becomes as summation minus 1 whole to the power of R into n factorial whole square by n minus R factorial into R factorial whole square into x to the power of R. R is from 0 to n. That is called as the another definition of Laguerre polynomial of order n, that is c naught equal to n factorial. So this is the another definition of Laguerre polynomial of order n. Now generating function for Laguerre polynomials. So this exponential of minus xt by 1 minus t divided by 1 minus t equal to summation ln of x into t to the power of n equal to 0 to infinity. This is called as the generating function for Laguerre polynomial. So to prove this, this is nothing but coefficient of t to the power of n is ln of x. So in the expansion of this, we have to prove that the coefficient of t to the power of n is nothing but ln of x. So now we will take the LHS, that is exponential of minus xt by 1 minus t by 1 minus t equal to 1 by 1 minus t into summation. This is in the form of e to the power of x, and we know that e to the power of x can be written as summation x to the power of r by r factorial. So summation r is, x is here minus xt by 1 minus t whole to the power of r by r factorial. So that equal to summation now this can be written as summation minus 1 whole to the power of r into x to the power of r into t to the power of r by r factorial into, now it is 1 minus t whole to the power of r into 1 minus t, that is 1 minus t whole to the power of r plus 1, and then we bring that 1 minus t whole to the power of r plus 1 to the numerator, you will get 1 minus t whole to the power of minus of r plus 1. So that equal to summation minus 1 whole to the power of r into x to the power of r into t to the power of r by r factorial into, now this 1 minus t whole to the power of minus r plus 1 can be written as this by the binomial theorem. How it is? Summation r plus s factorial by r factorial s factorial into t to the power of s can be written as r factorial by, so substitute s, first substitute s equal to 0, then you will get r factorial by r factorial plus s equal to 1, r plus 1 factorial by r factorial into 1 factorial into t, plus substituting s equal to 2, you will get r plus 2 factorial by r factorial into 2 factorial into t square plus so on. So this is nothing but 1 plus r plus 1 factorial by r factorial into t plus r plus 2 factorial by 2 r factorial into 2 factorial into t square plus so on. That is 1 plus, this r plus 1 factorial can be written as r plus 1 into r factorial, so that r factorial get cancelled. So you will remain only r plus 1 into t plus, similarly this r plus 2 factorial can be written as r plus 2 into r plus 1 into r factorial. So r factorial get cancelled, then the term is r plus 1 into r plus 2 by 2 factorial into t square plus so on, and this is in the form of 1 plus nx plus n into n plus 1 by 2 factorial into x square plus so on, that is nothing but 1 minus x whole to the power of minus n by using binomial expansion. So that can be written as 1 minus t whole to the power of minus r plus 1. So that this 1 minus t whole to the power of minus r plus 1 can be written as summation r plus s factorial by r factorial s factorial into t to the power of s. S is from 0 to infinity. So now this is equal to summation minus 1 whole to the power of r into r plus s factorial by r factorial into r factorial. So r factorial whole square into s factorial into x to the power of r into, now this is t to the power of r into t to the power of s. So it is t to the power of r plus s. So now r be fixed, then the coefficient of t to the power of n can be obtained by on the RHS by setting s plus r equal to n. So r plus s equal to n, that is s equal to n minus r. Hence, for the chosen fixed value of r, the coefficient of t to the power of n in this, the coefficient of t to the power of n is, so if you